Hello, my name is Ankur. I'm a software engineer here at Ferocial, Bendigo Bank, and I'm going to talk to you today. I'll share some examples of why Ruby is a tricky language to learn. So when we study any complex system, there's fundamentally two ways that we can learn. One is through rote learning, so like memorizing formulas for a maths exam. Or the other way is we can build a mental model. So we can find the patterns and interactions that explain what we see. So when we learn the underlying principles of the system, we learn quicker, we have more fun, and it lets us predict the system's behavior, even in situations that we've never seen before. But some things defy understanding. Learning English as a second language, for example, is a challenge because it's so irregular. You have to memorize all the exceptions. And my contention is that Ruby is the English of programming languages. Like English, Ruby borrows so much from other languages, which makes it whimsical and expressive. But at the same time, there's no coherent design principles that we can use to make sense of how it works under the hood. Let's see some examples. So Ruby has this simple idea that every operation is a method call. Addition is just calling the plus method, and you can even override it if you want. This idea comes from Smalltalk, where it's applied consistently. Whereas in Ruby, you add some precedence rules on top of that. So which breaks the consistency of everything is a method call. And it's not just for arithmetic. This is another precedence puzzle. Only one of these is going to print some numbers. Who thinks option 1 is going to print some numbers? Nope. Yep. Okay. Who thinks option 2 is going to print some numbers? Where's the participation? Come on, guys. Yeah, it does. So like this is something you just have to learn, that these have different precedents. So it's good to put some parentheses on there to make the precedents clear. Where Smalltalk has 3 simple precedence rules for the whole language, Ruby has 45 special cases. This is our first clue that the clear mental model we're trying to build might be out of our reach. Ruby is a high-level language. We expect it to have well-designed interfaces. These are some of the methods on the stat object. Who can tell me what nlink and ino mean? Hands up if you know what they mean. Okay, a couple of hands. These make sense if you know the C APIs that they wrap, right? So if you already know C, there's no problem. But if you don't, you've got to learn the C standard library to understand, or more likely, just fall back to rote learning. And so the implementation details leak through those abstractions. If the name looks weird, it probably comes from C, and that's where you'll find the real documentation. On the topic of abstractions, a proper numeric tower means that numbers work the way they do in mathematics. So you don't have to worry about things like integer overflow. So Ruby, just like the language scheme, even has a complex number type or a class, and it can represent the square roots of negative numbers. So complex maths just works in a language like Scheme, and in a language like Ruby, oh, no, domain error. Oh, you know what you got to do is install a gem, and then you can use that. So the language tells you it has complex numbers. You'd expect the math module to support them, but you have to remember to use a completely different library for it. Let's talk about scope. Here's a method called value. It just returns 99. And here's a map over 2 items. On the first iteration of the loop, a variable called value is assigned 42. And so that's going to be the result of the first pass. On the second pass of the same block, what do you expect this result to be? Well, okay, if it's a method call, it could be 99. If it's a local variable that's new, this iteration could be nil, or it could be 42 from the last assignment. Who thinks 99? Couple. Who thinks nil? Couple more. Who thinks 42? Yep. All right, so this actually is 99. It's a method call. There is a syntax to declare variables to be block local. I've never seen anyone use this. So what you normally see is an assignment at the top of the block. And it doesn't even need to be evaluated. As long as it's been parsed, it will turn that token into a local variable for that block. And I've seen even experienced developers add unnecessary assignments because it's easier to memorize workarounds than to reason about this path-dependent behavior. So to figure out variable scope, look for assignments, but not always. So here's our method again. And here's a regular expression with a named capture. We're going to use that to match against the string. Okay, what's value now? Who thinks 99? Who thinks nil? Everyone's scared. Who thinks Bob? Maybe. Okay, well, it is 99. It's just a method call. That's nothing surprising there. Let's refactor this. Let's remove the intermediate variable. Okay, what's value now? Who thinks 99? Who thinks nil? Who thinks Bob? Yep, it's Bob. It's that regex match has now created a local variable that shadowed our method. It appeared with no assignment operator inside. And it's not just that, it also mutated a whole family of cryptic Perl-style global variables, like the ones you see here, to hold the results of the match. And this isn't an isolated incident. Even raising exceptions also mutates global variables. These are not features you can derive from first principles. They're surprising historical quirks. Speaking of variable scope, when we need to pass context, like the current user, through every layer of our application, it clutters our methods and creates a maintenance headache. It's called prop drilling. Some frameworks invent magic, like Rails has current attributes, React has its use context hook. And this works, but it's a framework-specific pattern that breaks the normal scoping rules of the language. Other languages, like Common Lisp, solve this with dynamic scope, which is a kind of variable that is assigned for a duration of a block. And any function within that scope can access it without being passed down. It's a predictable language feature, not a memorized framework trick. Ruby methods are actions, they're verbs. And with service objects, we disguise our verbs as nouns. We create a service object or a command or an operation, not because it represents a thing with state, but simply to give the action a place to live. But this boilerplate goes away when verbs have their own independent existence, like in the language Dylan. In Ruby, we tell transfer funds to run. It's noun first. In Dylan, we just directly state the action we want to perform. With first-class verbs, the code matches our intent. So recognize that service objects are a workaround, but keep using them. Since we're on the subject of OOP, let's talk about inheritance. To understand a simple Ruby method call, you have to mentally trace a hidden cursed data structure. Languages like Python have a predictable algorithm to compute the ancestor chain for you. In Ruby, you are the algorithm. You use manual tools, include, extend, prepend, to perform surgery on the ancestor chain yourself. And the cognitive load is shifted from the language onto the developer. It's incredibly difficult to truly understand how this all works. And that spills over into the way we do metaprogramming. So we want to create a general def memo construct to define memoized methods. In a language with macros, you can. A macro is an explicit instruction to rewrite your code into a standard pattern before it runs. And this is so fundamental that even many of the core features in the language Elixir, like if and unless, are built this way. It's a system that you can reason about versus a set of powerful but opaque runtime tricks. And last example, Ruby has 3 different ways to do nonlinear control flow. That's 3 different ways to do the same thing, jump up the call stack. Common Lisp and Dylan generalize all of these into a single coherent thing. You signal a condition, and a handler decides what it means. It can unwind the stack, just like raise or throw, but it also adds a capability that's unheard of in most languages. It can handle the condition without unwinding the stack. So imagine a method fails because a file is missing. In Ruby and most languages, when that exception is raised, execution immediately jumps out of that method and to the nearest rescue block. In a Lisp system, the method can pause and ask its caller, hey, the file is missing. Do you want to try with a different path? Do you want to just retry the same thing or abort? And the caller can provide a new path and the original method can just resume right where it left off. It's a 2-way conversation, not a 1-way abort. So as we've seen, Ruby can be tricky. I hope I've left you with some insight into language design and some empathy for people new to your community. I've spent this talk arguing that Ruby lacks a coherent mental model, but I will leave you with one underlying principle that I think does make sense of it all. The unifying principle behind Ruby's design is that its behavior is decided according to whatever Mats thought was a good idea at the time. Thank you. Any questions? Questions? Oh.
That was really cool. I love Ruby, and I just nodded so heavily in my mind with every single slide. You seem like a bit of a languages nerd. I mean that as a huge compliment. Out of all the sort of more esoteric languages you've come across, what is the most regular one that you think you've found that has the most coherent mental model that is able to build the most of its features off like less concepts and less exceptions?
Well, I guess we all probably all have a different definition of esoteric.
Sorry, let's say non-mainstream, not like the ones with swear words in them.
So it kind of depends on the purpose, I think. So like, if you are wanting to build a business, it probably makes sense to find something that does have more users. If you're building a website, Ruby's probably a good choice. It kind of depends what you want to get out of it. So for me, the language that people are sick of hearing me talk about is Common Lisp, and that language I could have made all the examples Lisp. The thing that I find, the quote about Lisp that maybe explains why I like it is really that slide about the principles versus just disconnected facts. And so to me, it's not a language that I would recommend people to learn, because it takes a lot of investment and it's very different to mainstream languages. Like, it's a very different way of approaching programming, but it's a language that changes the way that you think about programming. And that's affected me the most out of all of them. I think there are a lot of good principles in things like Elixir, things like Dylan, which like these are not Dylan and Scheme. They're not languages that you would necessarily use, or even Erlang, but they help you to understand more what you're doing in your day-to-day. Yeah.
Cool, thanks. I'm going to come talk to you afterwards about why you said Common Lisp but not Scheme. Anyone else? Yeah.
Good talk. Always good to see Wise Guide mentioned, even if briefly. What other resources would you recommend people look at to understand more of Ruby's quirks?
I think Ruby documentation has improved a lot recently. There's not a huge amount of it, but the website, I think, at least since a few years ago, like, it's a lot easier to navigate and search. The example about variable scope, one of those examples was from the official Ruby FAQ on their website. So I think like reading the Ruby official FAQ is probably a good point. I don't think a lot of this probably doesn't matter. Like, it's interesting, but it's not something that is necessarily going to affect you, because if it's a language that you're familiar with, like when you speak English, like it doesn't bother you that, the same spelling can have two different pronunciations. Like, it's not something we think about every day. So like, if you like Ruby and if you use Ruby, if you're comfortable with it, you're experienced with it, like, it's not something that's going to bother you. You're not going to hit these problems. So I don't know that it's necessarily important to learn about these quirks, but I think it is interesting to understand Ruby better. Like that slide with the funnel, understanding Perl, Smalltalk, and Lisp, which is where Mats originally, he basically said Ruby is Mats Lisp. he derived a lot of principles from combining those three languages. So I think to understand Ruby's quirks better, if you understand those three languages, that probably helps you understand Ruby's behavior.
I only had joke questions because no one put up their hand,
Oh, yeah.
but I'll say them anyway. How can you say something so controversial and yet so brave at the same time? Don't answer that. Second question was going to be, you said that if you have a macro system, it's understandable, and isn't that not true?
It's a predictable thing.
Predictable.
So the thing with macros is they happen not at runtime. So your editor knows what's happening. Like you can expand the macro, you can see what it's doing. You can look at the code that it generates. And it's also like an input-output thing. So a macro is basically, it's a function that takes code as input and generates code as output. So it's like a template for if you see this code, turn it into this. So it's a lot easier to reason about rather than defining anonymous classes and like defining methods at runtime and that kind of thing. So it requires a lot less things to keep in your head compared to like runtime magic.
Yeah, agreed.
Do you find that top 10 list would change over time? So if you went back 2 years, what would be the 10 things that probably would have been on that list that may have been changed? Like how does the language kind of evolve and fix those things? So in another 10 or 2 years, whatever, would you see that some of those things would be being fixed?
I don't think they necessarily need to be fixed. Like a lot of them are just historical things, like the global variables are from Perl. That's how Perl works. It doesn't really bother us. It doesn't really affect us a lot. So I don't see all of these as things necessarily to be fixed. They're just interesting ways that it's hard to predict behavior from a set of principles. So it takes longer to learn, just like English. If you're learning Ruby and it behaves in this particular way that's surprising, it just takes a little bit longer to learn compared to if there were just a set of consistent, like in Smalltalk, you know, this, like there's 3 precedence rules that's always going to apply. If I look at this, I don't have to worry, is this going to happen first or not? Ruby does change over time, and like pattern matching and all those kinds of things get added to it. So yeah, I don't know that they necessarily need to be fixed as such, but I do see like you know, types and things like that. So there's always constant evolution. Yeah.
Brandon. I thought I was a bit of a languages nerd, but I've never heard of Dylan. That's not something you just made up?
So Dylan is a really interesting language. It was originally intended to be used for the Apple Newton, but they didn't make it in time, so it was never used. The reason I will confess that the reason I put up Dylan in there is so that every language example wasn't Common Lisp. Dylan inherited a lot of ideas from Common Lisp, but with a syntax much closer to Ruby. So it has a condition system like that lets you resume after errors and that kind of thing. It has multiple dispatch, multiple inheritance. It has a lot of really nice things in it that Common Lisp has, but with a syntax that without all the brackets.
Cool, thanks.
Oh, you're full on. I just wanted to flag that there's a weird overlap between the two talks, which is, of course, we're talking about Elixir previously. It's the pipeline operator, right? Which is essentially railway programming as a language feature. So that's Ryan's talk and this talk in one. You good?
Perfect.
All right.
Thank you.
Thank you.